All right, so we're back here with on measures of change from graphs. So calculating an average rate of change of a function between 2 points is the same as calculating the slope of a function that passes through those 2 points if you really think about it. Okay, so let's see if I can, so if we had a graph, something like that, and we wanted to find that average rate of change, uh, it would go, from maybe that point to that point. Well, we're just going to basically draw a line and find the slope. It's going to be the rise over the run. So that line that we actually connect those 2 points with is actually a special line. It's called the secant line. Okay. Now the slope of a secant line can be approximated by estimating the rise and the run for a portion of the line. Now, just for history's sake, the word secant comes from Latin secare, meaning to cut. And so the secant line cuts the graph of a function at two or more points, depending on how it is. Okay. So what we're going to do is we're going to have to draw a secant line. So they might give us a graph and they'll say draw a secant line from this point to that point, and you basically just draw that line. Okay, not very good, but you draw it. Okay, so this is an example here. So on October Madness, it's the scatter plot here shows the number of shares traded each day during October of 1987. The behavior of the graph on October 19th and 20th. I don't know why they say 22nd here, but that's okay. So I think it's probably the 19th, and that's probably the 20th. But they say the 22nd. Maybe they mean the 22nd's over here somewhere a little further, but I don't know. It has been referred to as October Madness. Okay, so they give us this graph. And now what we're supposed to do, because there's so many things, we're supposed to calculate the percentage change and average rate of change in the number of shares traded per trading day between October 1st, when they had 193.2 million shares traded, and October 30th in 1987, when 303.4 shares were traded. And again, it's 3.4 million shares. They left that off, and I just noticed that I just copied what they had in the book. And so that's our first part. The next one says draw a secant line whose slope is the average rate of change between October 1st and the 30th. Well, we can do that already. We don't even have to do that. So if that's really the thing, we just have to attempt to draw a secant line, which is between the 2 points. Okay, so that part's done. And then we're supposed to write a sentence describing how the number of shares traded throughout the month. How well does the average rate of change calculated in part A reflect what occurred throughout the month? Well, we can figure that out because we can see that's our average once we calculate it. But you can see, it went up and went down, then it peaked way up here, and then it dropped back down, and then kind of steadied off. So, overall, it fits the data pretty well. It got from here to here, but between there, it really didn't do it. So we'll figure that out here in a second when we actually do the calculation and see what it says. So for part A, what we want to do is calculate the percent change. Okay, so percent change is equal to, now remember, that's f of x2 minus f of x1 over f of x1 times 100%. Okay, so we're just going to plug in the values we do know. All right, so because these are on the y-axis, we're going to say, okay, well, our second one is going to be 303.4, 303.4, and we're going to drop million because when we divide, it's going to be that. We can just write million. The minus 193.2 million divided by 193.2 million times 100%. Now, I'm just going to plug that in my calculator. So I get 303.4 minus 193.2 divided by 193.2, then times 100. And so I get 57.039%. So 57.039%. Okay. So that's going to be my percent change. And it also says it wants the AROC, the average rate of change. All right, so AROC is equal to, now remember, that's f of x sub 2 minus f of x sub 1 over x2 minus x1. Okay, so what do we have here? Well, we have the same thing on top, 303.4 minus 193.2 divided by, now what is our denominator going to be? Well, now what we need to do is between October 1st and 30th, we need to know the number of trading days. So we have to kind of calculate all those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we have to divide by 22 trading days, basically, and then subtract off our last one because there was a total of 22. Subtract that first one. And now if we do this, 303.4 minus 193.2 divided by 22 minus 1. Looks like we get an error here. So let me check here. Let me pause and I'll figure out my error. All right, my error was I had no decimal place in the right place, and so it said error. You can't do that. So what I get is 5.248, and that's million basically shares per day. Okay, because these were the number of days. That's the number of millions of shares. So million shares per day. Okay. All right. So now what do we have? Well, now we did B already. B is on the graph, so we can come back here. We can say this is basically our part B. And then part C is how does it differ? Okay, well, let's just go ahead and put part C here because we're on this so we can see what it is. But we can say, the secant line hits the first and last values, but there is a spike, like we said. Extra letters here. There's a spike around, and that's not the 19th day. That's the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th and 14th day of trading. And so, which is outside of that range. Okay. And so that's, that's one of the things you could say, it's going up and down also along that way. But I think the key thing we want to talk about is this big spike because, there's, averaging out, it might be close to that, but that spike, it won't average out. It'll make it totally change what the actual linear thing is if you actually did a linear relationship with all of the data. Okay. All right, so let's pause there and come back to another problem.